Okay, cool. So yeah, I'm just here to talk about API testing. I mean, it's not 5 levels in terms of the traditional testing levels. So let's take that off the table. It's more like 5 stages or 5 phases of API testing. And I just want to kind of focus on like the things that we're trying about my company and like how it works for us. And you can kind of give me your feedback and let me know how it goes. Cool. So a little bit about me. I'm from Cape Town, South Africa. So it's a little short 14-hour flight. And back home, like it's quite like an IT hub in terms of like South African culture. If you didn't know, AWS was actually built in Cape Town, South Africa. So we're quite up to date with like kind of the latest in IT trends. My background, I've studied computer engineering. I've been in the testing game for like 13 years now. And I didn't kind of fall into it as traditional kind of testers have. I actually walked into it, and I wanted to do testing from the start and from the get-go. And then I kind of evolved my career from more the manual side into the more automated side. And talk about that. And I kind of see myself now as a full-stack tester, and I think the testing terminology or titles that have been thrown around in the industry is quite weird to me, and I feel like all testers are full-stack testers because you've got to know the system end-to-end. So that's just kind of a title that I use. And the company that I work for at the moment is Allen Gray. We're like investment company, so if you think about maybe like glorified online banking, we buy and sell trade funds and trusts and those kind of things. So our users in our platform will log in and like transfer money in, take money out, that kind of thing. So that's the kind of platform that we work on. Cool. Let's go. Cool. So I just want to give you a little bit of context in our infrastructure and like how we work and how things like kind of operate in our environment. So we're kind of a microservices shop, and we went down this journey probably like 6, 7 years ago around migrating our big .NET application to a kind of a microservice infrastructure. And our dev team consists of probably like about 150, 160 devs, 25 to 30 testers. And everything we do is around this kind of microservice infrastructure. And I kind of learned a new term from Roy the other day around like pipeline-driven companies, and that's kind of exactly what we are. And I didn't really know that term existed. And the way we kind of set up is that each of the teams are full agile teams, and they're full-stack agile teams. And by full-stack, I mean they do everything from kind of design concept right down to front-end implementation, which we do in React. And then if there's API work to be done, and database and infrastructure work to be done, they also do that. And we also kind of adopt the DevOps model. That means if a team actually builds a feature, they see it from inception all the way into production and post-production. So they're also supporting it after it goes in. Yeah, so that's the kind of mess that we're looking at in that picture. It's not what microservices are, like according to the textbook, and what we call this is more like a distributed monolith. But yeah, the way we divide it up is that each of those APIs, you can see the different colors they kind of represent around the different teams, and each of the teams own a certain number of APIs given their domain knowledge. And then they all deploy it into a shared environment where we test. And those shared environments basically talk to each other, and the databases are shared and the infrastructure is shared. And the reason why we kind of went down this road is to be able to kind of fit into the CI/CD kind of pipeline where each of the teams can develop their APIs independently, build them, sign them off, put them in the environment, and then deploy to production as and when they need to. Cool. Yeah, so like some of the key like automation principles that we set up at Allen Gray is some of the things I want to touch on. The main thing that we do is a very programmatic approach. So all of our automation is not like based on like tools like Postman or things like that. And the main reason for that is we kind of wanted to break down the barrier between dev and testing in terms of automation. And the 2 ways we kind of do that is by having a programmatic approach, and also that the test code lives with the feature code. It's not in a separate repository. It doesn't run like a separate job. It doesn't run as a separate kind of entity that somebody has to pull down. If a dev touches the feature code, those test code will run because it's in the same repository. And if it needs to be fixed, either he fixes it or he gets a tester to fix it. And that depends on the level of the team and I guess the competency of the tester in that team. Because obviously all testers, we're trying to move them over to kind of be more technically sound, or test analysts, as they say. But yeah, everyone's not equal, and some of them aren't programmers at heart, so they're not going to be able to write that code. But what they do then is they support the developers to actually maintain those tests in those repositories. Consistency there, I mentioned about consistency being king, because the one thing that I don't want them to be doing is kind of building up more barriers that say, your repo has different tests than my repo, and my repo has different tests from your repo, and then you spend 3 or 4 hours trying to figure out why they tested the thing in a certain way. So having things consistent just kind of makes it easy and to kind of chop and change. I didn't mention that the actual APIs in that environment, we have like around like 70 to 80 of them, and each of them have about 10 to 12 endpoints each. So that's like 700, 800 endpoints that we've got to kind of test and maintain. And the last kind of principle there is that automation is not the goal. Testing is the goal, and quality software is the goal. So we see automation as a tool, just to like kind of move forward with our testing. So I thought the best way to kind of explain this would be kind of to use an example so that we can kind of walk through the different levels of testing or the different phases of testing that I want to introduce. And this is what I kind of see when I see a traditional API test. This is just like a kind of people search endpoint. You put somebody's name into the query param, and you get back a typical response. I had an interesting conversation with Voltic earlier around like what is a correct response, and I'm like, do you just check response 200? Do you check other things? Like, what do you do? And he's like, oh, it's just a correct response, so you need to go chat with his developers around what correct response means. But cool. So yeah, that's what I see. So then you question yourself and say, like, why do you need to split this up into different phases? That looks like a good test. Looks pretty solid, does what it says on the box. But when I look at it a bit differently, right? So the first thing I see that I actually need legit data. So like, I need that name to exist in the database. So when I try to retrieve it, I actually get a response 200. If not, then maybe I put in a bad name and I get back a 200, but then it's still an empty array or something like that. The second thing I think about as a tester is like, okay, this is always going to return a 200 if I have like good data. How do I start simulating other response codes, and how do I start breaking this or trying to test differently? The third one I see there is like, okay, maybe I might want to do a bit more clever checks. I might want to check, hey, that the body is actually coming back with some kind of response, or does the actual name actually equal what I searched, right? So you want to check some content validity there. Then you start thinking about, okay, the things that I'm going to, like thinking like a tester, start thinking about special characters, people with characters in their names, different countries, those kind of things. The last one there for me is a big one. Like, the major blocker for kind of testing this API is that this API has to be deployed to an environment for me to even start writing these tests or running these tests. So that's a kind of like a big hindrance for me, and I see that as a big red flag. If you're only testing, like at this point, that means this API has already been like kind of thought about, spec'd, developed, unit tested, integration tested, and now you're like trying to kind of follow up with the automation tests. And then my favorite one in the shared environments is that it ran 15 minutes ago, and now somebody went and deleted shakes from the database, and I can't find it anymore, so now I got to patch up the test, right? So I'm going to be kind of like talking about addressing these things, and the way that I kind of address it is with these 5 levels, and like I said, don't take the names or the number to heart. You can kind of split this up this way you feel fit, but I just kind of gave them a little bit of meaning. What industry kind of calls component tests are kind of rebranded into acceptance tests, and the main reason for that is that I see it as a place that you can kind of test the acceptance criteria of an API. And the component test traditionally is like you treat the API as a black box and try and mock its surroundings. Verification integration tests, kind of similar to what you understand now, is like, do APIs talk to each other? But there's a little spin on it that I'll talk about. Smoke tests, traditional to the testing term, like tests that happen after a deployment. Synthetics tests I stole from kind of the monitoring world, which is tests that run periodically, like over time. And then the last one I kind of came up with is like this data chaos monkey tests, where we actually kind of try and actively retrieve data from production and use that in our tests rather than just faking it all the time. Yeah, and the last point there was just around that, like the assumption is that you're still writing your unit tests and your integration tests as per normal, as devs would do. It doesn't replace them. This is just in addition to. So this is like one of our traditional APIs and what they look like. It has an API, the one under test is the one in orange. It has a number of dependencies, and those dependencies could either be another API or a database, or maybe like a rabbit message queue system or something like that. So what we do in terms of the acceptance and component test, which is, like I say, we want to try and isolate the orange circle, right? We're trying to isolate the API under test, and the way we do that is with a proxy. And the proxy that we just use a Docker container from like James D. Bloom, mock server. And that, if those that don't know what a proxy is, it just kind of intercepts anything on the network, right? Any kind of network traffic, it's going to intercept and kind of replay whatever you want. And we set out the the mock data, as you can see there, are just like flat JSON files, and those kind of replay the responses that I want at any point in time. And then we also kind of control like a CI/CD database. And then we also start up our own RabbitQueue at that instance. And you can see everything there is controlled by the test suite. So there's no like parts that's actually deployed like outside of that. Everything happens within the test itself. Cool. So in terms of technologies, the things that we use, our whole infrastructure is kind of Dockerized, and every service and API that we build is in a Docker container. And that gives us kind of freedom that we can write them in any language that we want. So the API under test here like could be a Scala, Golang API. It doesn't really matter. It's just going to be like an HTML URL. And we chose Jest and JavaScript as our testing kind of framework of choice. Just if you haven't played with Jest, it's quite like verbose and has like a lot of cool, neat stuff. And because it runs in its own Docker container, you can kind of swap that out for whatever kind of language you want. We chose JavaScript as being our consistency because we kind of moved to React frontend. So JavaScript was just everyone is upscaling with it, and we've got the support from our devs as well. Cool. The other cool thing is that that Docker container of that Orange API, the one that's built, that's actually started, and the one that I'm testing, is the same version or the same Docker container that's going to get shipped all the way to production. So I'm quite confident here when I'm testing it, even though it has mock dependencies, I know that I'm testing the right service, or I'm testing the right version of the service. And that's quite important because a lot of time if your code is still evolving, or you're still adding on things, or you're still doing additional configuration down the line, then you lose confidence in your kind of upfront unit tests and your upfront integration tests because you keep changing your API before it actually gets deployed. So in this example, our person API has like 3 other dependencies: bank details, contact details, and account info. And you can see here, like in the orange block on the side, is that those are all the things that I can kind of test now because I have the freedom. This is like the tester's holy grail, right? Every tester dreams of a place where you can kind of control your entire ecosystem, have the API or the system that you're testing isolated, and then kind of control all the moving parts around it. So here, what we do is like you can test any type of method, the gets, puts, posts, and deletes, without actually affecting the database or affecting data in a common environment that like other testers might be using and might affect you, right? The other cool thing here is that I can actually like now start faking responses. So if API bank details, for example, goes down, like traditionally I might have to call up like the team that owns bank details and say, hey, can you please shut off your API for 5 minutes? Let me test the scenario quickly. Whereas now I can actually fake a response and say, hey, if it gets a 500, what do I do and how do I respond? Cool. And then, yeah, in mix mash of dirty data scenarios, any kind of edge cases that you can think of, you can kind of put it in here with those mock files. Right, so that's traditionally like what one of our tests looks like. We just have this mock server that loads up a bunch of fixtures, hits the URL, and you can see there the major difference is that now I'm hitting like a local version that I just started up. And the other cool thing with Jest that you can do is that you can do snapshot tests, so I don't actually have to worry about any particular assertions, because, or what they call like approval tests, is that I'm taking a snapshot of the whole response, like whatever's in it, headers, response codes, body, wherever it may be, and that's like snapshot, and then that's saved, and whenever it changes, then I kind of have to approve it or reject it, and it comes up like a little cool Git diff, so I can actually tell what's changed. But it's all fake news, right? Like everything around it's fake. The only thing that's real is my API, and nobody's going to sign that off and go to production just like that. So the next layer will kind of be like, can I actually talk to the APIs that I actually need to talk to, right? So like traditional integration tests. And this is about maybe understanding how your API was built and making sure that you hit only the endpoints that you know are going to touch different integration points. So you'll focus on things like that. Maybe you'll focus on the 80-20, kind of like all the critical cases. But it's a very small subset of tests that you would do here. And the major difference here is that what we do to create this environment, and we use Git Lab as our kind of CI/CD pipeline, and what you can do in Git Lab is you can create Ringfence namespaces, which is basically like a Ringfence environment. And I can tell it to start up all those services that I depend on, and my API under test, and as well my test suite container, and now I can have all of them talking to each other, and those Docker containers of those like orange or yellow, blue, and gray APIs are the actual APIs that I depend on in production as well, or the right versions of them. And when they start up, and then I can test things like contract testing here becomes like quite important, because then I can actually say that the contract between the API I depend on and the one that I'm testing, the contract still holds true. Cool. Anything else I want to say? No. So now, like, we've written all these tests. We've got like quite high functionality tests with the acceptance tests, and we've got like some integration level tests, and I'm ready to go to production. So you click the button, or you're ready to go to your dev environment. You click the button, and you go into the dev environment, and then like, everything is cool, right? So like once you see that pipeline go green, you're like, everything should be fine. And we know as testers, like, it doesn't always work like that. So then we kind of write tests that come after the fact, which is like post-deployment tests. And those are like smoke tests that will just run very basic get data scenarios, or like the get endpoints, because again, I don't want to manipulate the data. And then any kind of third-party integration systems that you might not be able to simulate in the Docker environment. Cool, so now like once you actually got this thing in the environment, you can actually start testing, right? Like those were all just automated checks. Like now you can actually do the exploratory stuff, the UAT stuff, and all the cool stuff that testers actually want to do. And then we're ready to kind of say, like, after we pass that cycle, we're ready to go to production. And then the last thing to kind of go into production is that when your API is actively worked on, and if your APIs are actual microservices, you're writing those tests up front, and you're writing them early, and they run when the API is worked on, right? Like they run when the branch is created, they run when the master is merged in, or whatever it might be. And then the question becomes then, if my API is in production for a long time, and these tests aren't been running, do I actually still have to test my API and make sure that it's fine? And the short answer is yes. And to do that, we kind of have monitoring and monitoring tooling, and then tests that kind of run periodically. In our environment, we unfortunately don't have expensive, fancy, like Dynatrace and New Relic and monitoring tooling in our test environments, as it's like pretty expensive. So we kind of write our own little tests that just run on a cycle, and you can do that kind of configuration with Git Lab. You can tell it to run periodically. And why we do that is because the APIs change, right? Things around you change. And although your code might not have changed, but dependencies might have changed, contracts might have changed, data might have changed. So you definitely want to run those tests. The price that comes with that is that there's a culture shift in the teams. So if you have tests that run periodically, you have to make sure that you have like proper alerting and monitoring in place and reaction to those alerts. If nobody's looking at them, then you've got another problem there, because now there's no point in having great tests, but nobody's looking at the failures and making sure that they work. And for that, we have like Grafana and Prometheus, and we have a whole bunch of monitors on the floor that kind of tell us information about whether the pipeline's always green or not. Cool, the last one I'll talk about is this kind of data chaos monkey test. And this is a kind of thing that I've been playing around with, kind of like poor man's AI, I would assume. So we just write like a bunch of SQL queries that are written like in a wrapper, in a node wrapper. And what it does is like it kind of like polls the database and kind of gets different scenarios out. So say, for example, I want a guy with no bank details or like a zero balance account. So I'd write the SQL query for that, I'd wrap it around in a JavaScript function, and then I'd call that function to get that data out dynamically rather than like going and mining for it and then like hard coding it in my test. Yeah, and also because like why we want to do things like this is because our users are crazy, right? Like they do crazy things with the data, there's permutations and scenarios that they come up with like I couldn't possibly dream of. So to get that information out of production sometimes is useful. So how the test would look like that, it would look, I mean, for those chaos monkey tests, it would look like something like that. So that's the kind of function that I'm talking about, like get a random kind of name from the database, hit your API, get the ID out, get another name from the database, and try to update the first one with the second one. Like, you know, it's a kind of a different thinking around the test, but it kind of gives you that flexibility to think that, hey, the data in production will still work for my API. And like I said, these kind of tests are going to like pass 99 times out of 100. But then one time that it does fail, it's going to point you in the direction of like, hey, there's a dirty data scenario here that we haven't catered for, so let's go and like patch that up. So our pipelines look like this, and this is how GitLab kind of represents them. So the Docker image that I was talking about like gets built. We then run the acceptance and verification tests in 2 different jobs, maybe in parallel, maybe not, up to you. And we then deploy them like to the dev environment or somewhere, and then run the smoke tests, and then synthetics tests, and then the chaos monkey tests. And usually like the acceptance and verification tests run on a branch level. So whenever we create a new branch, they'll run. But on master pipeline, then we'll just have the smoke tests and the synthetics tests and the chaos monkey tests. And you can see the kind of separation there between like the different types of things that I'm trying to test, right? I'm not just trying to test response to 100 while it's deployed to environment. I'm trying to test the functionality in the acceptance test. I'm trying to test connectivity with integration or verification tests. I'm trying to test the deployment with the smoke tests. And I'm trying to test stability with the synthetics test, make sure that it's still working in the environment, although other things might be changing in this microservice architecture. And then I'm trying to test the data with the chaos monkey tests. And that's me. Thank you.
Thank you, too. And now, as usual, let's see the questions of the audience.
Cool. Aren't you afraid of the maintenance of so many test cases and methods, 500 missing data, no combination, etc.? I think that it's going to come with a cost anyway, right? Like, you're going to be maintaining those tests somewhere. The cool thing is that the maintenance is spread across the team. Once you start putting code into the feature repository, it doesn't just become the tester's problem or the automation tester's problem to maintain those tests and keep them running. Once it's in the pipeline that's stopping your API or your service from going to production, it becomes the entire team's problem. And it's kind of like we have a very good culture about like this whole team testing approach. So if a test does fail, like the default is for like the dev that touched the code or that kicked off the pipeline is to go and fix it. And if he can't fix it, he'll kind of refer it back to a tester or ask them like what they were kind of doing. And it kind of breaks down the barrier there to say that, hey, the maintenance of this is a whole team and not just like the individual or the tester that wrote it. And I feel like testers have this, or automation testers generally have this like attachment to their code. Like I wrote it, I'm the only one that can maintain it, and I'm the only one that's going to ever build this thing ever again. Whereas developers like will freely like hand over their project to someone else, and developers aren't afraid to touch other people's code, and that's also kind of what we want to do here. And because we have so many microservices, the testers will jump from repo to repo as well. Why are you separating test environment? Why separating the test environment for integration tests? Oh, yeah, because that's just before it actually gets deployed, right? So I don't want to, why we do the namespace Ringfence environment in Git Lab is because I don't want to affect testing that's going on in the shared environment. So I want to make sure that kind of the API works well before I can actually deploy it, rather than deploying it and then running tests. Whereas in a microservice architecture, if like one kind of piece of the puzzle falls down at the bottom, then all the APIs crash, right? What's the difference between synthetic and smoke tests? In terms of the tests themselves, not much. The major difference is that smoke tests will just run once after the deployment. Synthetic tests will run periodically. So it's kind of like a distinction there. They might be the same tests, or they might not be the same tests. For me, we kind of optimize the synthetic test for performance. So if I'm hitting the search API and I search the letter A, and I get back 10,000 results, that might be a good smoke test. But if I run that every 5 minutes, it might put a lot of strain on my test environment, so I don't want to do that. So I might put a more specific name and optimize for execution on the synthetic side. Cool. I think I answered that one. How do you know if there's a change in the API? Do you handle situations? In this case, there's an update. How do you handle situations in this case? There's an update. So the change in API is inevitable by the code going in, right? So all these tests are written in the API itself. So this is not a separate repository or not like anywhere else. So if there's a change, the code that's changing will trigger the pipelines, and then you'll kind of know like that. And if there's dependencies that change and dependent APIs that change and contracts that have changed, we usually have like those tests to kind of break at that point, and then we'll like deal with the owning team of that API. How do developers communicate their changes they do in the input and output of the API calls? Do they inform the testers, or testers need to find out for themselves? Like I said, it's the whole team approach. So if a developer is making a change, we all have access to all the code, right? So in Git Lab, there's nobody that's on the floor, from product owners to domain owners to BAs. Everybody can see the source. And we actually spend a lot of time as testers or as analysts actually reviewing the MRs as they come in, or the pull requests. So a lot of the time, we'll know about the changes well before it's even merged into the master branch or into the dev environment. Do you mock the database? No, we don't mock the database connection in there when we test the API. We actually just connect to a CI instance of the database. So we have like empty kind of databases that we'll kind of inject data into, rather than the big kind of production one. So we'll clean them out every single time, and we use like Flower migrations to do that. So every time we want to run a test, we spin up the database from scratch all over again. Do you have a tool mix, Jumpstart and API testing on web-based project released for a POC goal? Do you have a tool mix to Jumpstart API testing on a web-based project, at least for POC goal. So my tools of choice, like I said, we're very programmatic in nature, so it's not really like tools. So because we're using JavaScript, there's a number of like HTTP request libraries out there. We use request promise in our case, which also kind of addresses those asynchronous problems and things like that. Jest is also a great tool if you're doing like, if you got JSON payloads or JSON responses coming back. We used Jest to do like the object matching. And then we also use Joy, which is like Joy is a schema diff kind of tool to help with the contract testing. That's my time. Thank you, guys.